Hello guys, welcome back to my channel Algorithm Minds. My name is Asan Khurram and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach theoretical concept as well as practical programming skills in data science, data analysis. So I request you to subscribe to my channel and hit the notification bell icon button. So I have been producing a series of tutorial video regarding data visualization for marketing analytics. This is where I actually take a marketing case study and use that data, and with the help of a compelling data science and data analysis technique, I was able to come up with some interesting data visualization or data plots. So for today's tutorial, we are going towards the advanced data visualization for marketing analytics. This is where I actually teach you how we can actually plot a Sankey diagram in Python using a marketing data set. So you can see that this is a Sankey diagram. We have like on the left hand side we have marketing channels, on the right hand side we have the customer age groups. Okay, so with the help of this Sankey diagram, if you are working in a marketing firm, you can actually help them visualize that most of our customer base is within the range group of 21 to 30 age, and we can see that most of the traffic that comes or most of the marketing channel that was able to acquire customer was actually direct. Then on the second number we have something like organic search and so on for the paid search, affiliates and paid social. That being said, so this is a Sankey diagram. Then this is what we are going to produce by the help of Python and its library called Plotly. So let me jump over to code environment. So this is a Jupyter notebook, and the libraries we are going to use are Plotly and pandas. Okay, the pandas will be useful in order to pre-process our data and create age segments for based on the age column, and Plotly will be used to plot a Sankey diagram. That being said, let's move on and actually import our data set. So a data set in our case is actually a CSV file with the name df underscore customer, where I have initialized a variable name excel underscore file and store its value. Then I use pandas function read underscore csv, and I'm passing input argument the file name, and I was able to extract data and store it as a data frame. Once I have imported the data, let's visualize the first few rows of our data set and discuss about it, what that data set represents. So we have like customer ID column, we have gender, like whether the customer is male, female, we have date of birth, we have its location, where you have contact allowed or not, we have registration date, then we have marketing channel type. So this column represents that specific customer was acquired by what kind of marketing channel, whether this customer was acquired by organic or was acquired through organic search, whether he was acquired through affiliate marketing, paid social and so on. Then we have first order profit, subsequent order profit of that is the profit that the company make based on customer's first purchase and based on customer subsequent order purchase. And then we have subsequent orders count, like whether the customer after purchasing from a company becomes a repeated customer. If he becomes a repeated customer, then we have already stored the total number of repeated times the customer has bought a product from a company. Then we have total value of all promotion. This is actually what kind of promotion discount a company has to give to a customer in order to make him purchase the product. And then we have age column and we have total profit column. So basically we are three columns we will be looking at. Will be the first one is actually the marketing channel type. The second column is actually the age of the customers based on that. Okay, so right now I told you like we have to actually create a segment of customer based on their age group. For example, a customer aging, like for example in the first row is 39, he must lie within the age group of let's say 35 to 40. So this is exactly what we're going to do. We are going to create an additional column in our data frame that will contain the labels based on the age that is customer has. Okay, so the label would be something like this here in the label list here, 0 to 20, 21 to 30, 31 to 40, and so on. And so we will create a column, an additional column that will contain those label values based on what value is currently present in each column. Okay, so how we are going to do that? We are going to do that by using cut method of panda data frame. So first of all, we have to create a list of which we have. First of all, I have initialized a variable named bins, and I have passed its value equal to a list of intervals. Okay, so here it contains the range of intervals where you actually want to create the range. For example, the first range will be from 0 to 20, the second range will be 20 to 30, and so on till 60 to 100. Okay, so bin actually defines the range of intervals you want to create. You can change it to, like, for example, you are more interested to create a range of intervals of with an addition of 5. For example, you create a range like 20 to 25, 25 to 30, and so on. But right now here we are creating a range of 20, 30, 40, 50, 60, and 100. The next thing we actually need to do, we actually need to create labels that will be associated to the age column. So whether the customer lies in the range of 0 to 20, 21 to 30, and so on. So once we created bins and label, we are going to create an additional column in our data frame by using this Python statement data, then square brackets, and writing the new column name that we actually want to create. Then I'm equating its value, and finally using cut method by panda data library. And we are passing number of input argument. The first input argument is data with the square bracket age. So this is the column that we will observe, and based on this column value and based on the bins we have created, we will add value to the age group column. Okay, so the second input argument is the bin, which will create the intervals for our label. Then the third input column is actually the label that will be used to assign to that column. And right is equal to false. So right is a bit tricky to understand, but right is equal to false means that each bin interval is closed on the left and open on the right. So the ages in the ranges 20 to 30 will include 20, but it will exclude 30. That being said, let me just run this code for you. Now visualize our data frame. As we scroll to the very last, now you can see that we do get a column called age group, where it has been the values have been assigned based on what value we have in the age column. For example, for the first row we have age 39, so this person lies in the range of 31 to 40. So it's so basically it's being labeled based on what the age is present. Then we have 28, it's in the range of 21 to 30. Now once you have done that, now what we are going to do, in order to plot our chart, we are going to create an additional data frame, a new data frame, by using the method groupby. So first of all, I'm initializing a variable name age underscore channel underscore count, and then I'm equating its value, then writing the data frame source data, and then using groupby method. And I'm passing two columns here from the data frame data, and then I'm applying this method dot size. So what does this dot size actually do? It actually counts the number of occurrences of those both based on those both columns. Okay, so it will count the number of occurrences that occur based on these both column. And finally, we using rateSide underscore index that will actually create a new data frame that will have three columns. First column will be the marketing channel type, the second column will be the age group, and the third column will be the count of those values. And finally, you can rename that column that contains the count value by using this statement input argument here, name is equal to count. So by doing that, we have created a data frame which looks like this. So for it has a column marketing channel type, it has a column age group, and it has the number of occurrences for specific age group under the affiliate marketing, and so on for the other marketing channels as well. So once we created that, let's move on and actually go towards the section of Sankey diagram. By the way, I have already published the videos regarding tree map, how to create a tree map in Python, how to create a sunburst plot. So I will put down the link of those video in the description for you. So I suggest you to go and check out that video as well. So let's move on and start by first of all, we are going to import libraries. So the important libraries that we are going to import are again Plotly. We are going to import plotly.express as px. Then we are going to use this Python statement, import plotly.io as PIO. Then finally, in order to create a graph object, we are going to import plotly.graph object as go. Okay, once we've done that, we are setting an option here, pio render.default is equal to browser. So basically it says that whenever the plot has been generated in Jupyter Notebook, instead of actually plotting it in the output column, in the output space in Jupyter Notebook, it will actually plot it in a different window, just like it. So that option actually helps your plot to be displayed on another tab, which give us the option for larger view area in order to display that chart, as well as for interaction as well. So that being said, let us import our libraries. So a brief introduction about Sankey diagram is such that Sankey diagram represents the flow of data from different categories using arrow. The width of each arrow is proportional to the quantity it represents, making it easy to visualize the relationship between categories. So what are the key features of Sankey diagram? So first of all, it has directional flow, ideal for showing how data flows from one category to another category. It also gives the proportional width. The width of the arrow corresponds to the quantity, like the number of counts in our case, making it easier to compare values visually. And categorical relationships effectively shows how categories are interconnected. So okay, once we done that and imported our libraries, so what we are going to do, we are going to create labels and indexes as well. Okay, so in order to do that, what we are here doing, we are initializing a variable named unique underscore label. Then by using this unique method, we are extracting the unique values of the column marketing channel type, and we are also extracting the unique values of the column age group, and we are using plus operator to make a combined list based on the unique values that are present in marketing channel type and that are present in age group column. Once we done that, we will have a list that will look something like this. Okay, so here you can see that we have unique values of marketing channel type, then we have unique values of age group, which in our case were the label we have assigned to create a column age group. Now that being said, so in order to create a Sankey diagram, we need to refer to each label, organic search, or for example the label of age with the numeric index instead of the string label itself. So in order to do that, we will use a dictionary comprehension. So basically what we are doing here, we are actually creating an index to the label. Okay, this affiliate will have an index of 0, this direct will have an index of 1, and organic search will have an index of 2. It's important for us to do that because by doing that, we will be able to generate Sankey diagram. So first of all, in order to do that, we will create an empty dictionary label underscore 222 index is equal to empty dictionary. So after that, we are using the list of unique labels and we are enumerating through the list. By enumerating, we are actually extracting the value as well as we are creating an index. Okay, so here we are appending the dictionary with their respective key, and index is a value. So the for loop will run for the unique values or unique labels, and it will create a dictionary with the key will be the unique label and the value will be the index here. So let me just run this block of code for you. Now you can see that our labels for marketing channel types and age group have been labeled from 0 to 10. Once we done that, now the Sankey diagram needs two components: a source where the data flows begin and a target where it ends. So basically the Sankey diagram needs two source where the data begins and target where the data ends. So in order to do that, we will create two additional columns in our data frame. The first column is called source and the second column is called target. And by defining this using this Python statement, writing the data frame name and square bracket and writing the new column name, we are able to create the column. Okay. Now here, what we are actually doing here, we are using mapping function and using label to index, which is actually a dictionary that contains the index of the labels. We are using this index to label dictionary and passing it as an input argument to the function map, and that will actually create an additional column called source, which will contain the indexes based on what value is currently present in marketing channel type. Okay, for example, if the marketing channel is affiliate, it will store a value 0 in the column source. And we will do the same thing with age group, and we will pass input argument map label to index as an input argument to this function method map, that will actually store a unique value for whatever the value that is currently present in age group. So let me just run this block of code for you. Once we run that, now I will just go through the data frame and visualize first few rows of the data frame. Now you can see that we have successfully created two columns. The first column is source and the second column is target. So you can see that for affiliate we have an index of 0. So you see that we have an index of 0. For the age group 0 to 20, we have an index of 5. For the target, we have an index of 5, and so on. Now that being said, the another addition or customization we are going to make to our Sankey plot is that we are creating unique color codes for each age group. And it is quite easy to do. So in order to do that, a unique color code, we will create a list which will have a same length as compared to the labels. Okay, so you can see that here each label has a different color except marketing channel types. All marketing channel types have the same color, while age group channels have the different color. So in order to do that, first of all, we are going to create a list of colors that will correspond to each age group. Okay, we have like 6 color codes for different age group, and then we will use the same color code for marketing channel color. Okay, that being said, so in order to match the length of the number of labels, so we will first of all create a list of 5 elements that has the repeated value of this quantity here, and we are doing it by using this thing. Okay, so by using age channel count marketing channel dot unique, it will actually extract the unique values that are currently present in marketing channel type. Then we are using learn method, which will actually calculate the total number of unique values that are present in it. So in our case, it is actually 5. So here 5 is multiplied by marketing channel color. So we are creating a list of 5 elements that will have the same value here of marketing channel color. Then we are using plus operator when we are adding the values of age group color. So that's how we create a list of color codes. Now you can see that the first 5 will actually represent the color codes for marketing channels, and the last 5 or last 6 will represent the color of age group. Now that being said, let's move on and actually go towards our main segment of code, which we actually plot the Sankey diagram. So this Python statement here, go.figure, will actually create a figure in plotly environment from the data Sankey diagram. Okay, here go.Sankey actually is a function that will actually help us to create a Sankey diagram. Then here we have 2 dictionaries. First one is called node dictionary and second one is called link dictionary that we will use in order to define our Sankey diagram. So let's talk about first of all node dictionary. The node dictionary defines the appearance and layout of the nodes in the diagram. So whatever the appearance and layout of nodes that is currently present in the diagram, that has been done by node dictionary. For example, you can see that how much padding is there in the each node, how much thicker the node is. You can also see a black line outline on the every node. So this is what is actually defined by node dictionary. So we will write node is equal to dict and then round bracket, we will passing a number of input argument. The first input argument is pad is equal to 15. So this pad represents the space between each node. Then we have the thickness of node is equal to 20. So we are here, you can see that the nodes are being broad. So in order to graphically or visually see them distinctly. Then we have line is equal to dict, color is equal to black, and comma width is equal to 0.5. So basically we are passing dictionary as an input argument. So where color is black and width is 0.5. This is done in order to create a black outline around each node. Then we have color of nodes here, which will be used. What are the color of nodes? Okay, so in our case we are using node colors, which we have already created in the previous code section. Now let's move on and talk about linked dictionary. The linked dictionary set as the line between node representing the flow from marketing channel to age group. So this is actually where you actually define the links of Sankey diagram. So the links that starts from source and the link that ends on target, and that link has some specific value that will actually help us generate the width of the link. You can see here each link has the different length or width. So that's how that is defined by here value parameter. So we are passing multiple input arguments. First one is source, the second one is target, the third one is value, and the last one is color. Okay, so what is the source? Source is actually the source column we have generated that contains the index of marketing channel type. What is the target? Target is the index of age groups, and value is actually the count that defines the width of links in the Sankey diagram. Finally, we are setting the color of links, these links to be blue with some transparency. So by using 0.5 as a transparency. So these are the input arguments that you are going to give to the Sankey diagram. And finally, we are using this function here, fig.update layout, and this passing two input argument. The first input argument is actually the title of the plot, and the second input argument is actually the font of the title. And finally, fig.show function will actually render the plot in a different tab environment. As you can know, as you already know, we are setting this option here, which will help us to plot this diagram in a separate window. So let me just run this block of code for you. Now you can see that we have successfully plotted our Sankey diagram, where we have on the right hand side we have age group, on the left hand side we have marketing channel type, and this width represents the number of occurrences in our data set. So I hope this tutorial have been helpful. If you need to ask any question regarding today's tutorial, feel free to write down your comments. I will be happy to help you out. So I will be publishing more tutorial videos regarding advanced data visualization, as well as carrying out a whole complete data analysis case study in Python and also in R and Tableau. So I request you to subscribe to my channel and hit the notification bell icon button so you can get the notification as soon as you publish the video. Thank you for joining me, and I will catch you soon in the next video.